Okay, we're starting the recording of the second part of the PC analysis. Let me see if we could share the presentation. Okay. I hope it will come up on the screen, and then I'm gonna try to flip it over here so that I can use my pen. Okay. Let's see if this would work as well. Okay. All right. Okay. All right. So at least the okay. All right. Things are going. Okay. So let's see where we started. We started our PCA analysis by suggesting, let me go back to the earlier slides. Okay. This is going forward, and this is okay. So we said that the basic idea of this analysis is see if I can, yeah, I can show the laser pointer here. So the basic analysis is that I do have a K samples, and then I have an N features. And the idea is to reduce these N features into small N features. We say this is very important for simplifying computations and reducing the storage area. Fundamental. So then we established that there are multiple types of algorithms, right? I do have the feature selection type of algorithms, which says that you have the set of features and you select some of them. And we say that these are kind of not very efficient, in particular if you have correlation between the features. And then we looked at the feature projection algorithms, which is basically create a new set of features, and these are more powerful because what they do, they create new orthogonal, uncorrelated features. Okay, and that's better for the results. Okay, then we started on the PC analysis last time. Okay, and we looked at some of the fundamentals of this algorithm, and basically we looked at this example of having two variables, all right, and multiple samples. حكينا and these two variables can be any feature you can think of. If you have, for example, these S1 and S2 and S3 as students, you can have X and Y as weight and height. For example, you are collecting this data about students. You can have age and GPA, for instance, right? You can have whatever two features. So the point is X and Y are the variables, are the features, are the attributes, and S1 and S2 and all the way to S6 are the samples. Let me change my pen here. Okay, so I want you to make sure you differentiate between the two. Some students, for some reason, they confuse the two. What are samples and what are features, right? In this algorithm, which is the PCA, what do I reduce? Samples or features? Features, right? You don't reduce the samples. Sample stays there. You are sampling 100 students. Before PCA, there will be 100, and after PCA, there will be 100. But you start with, let's say, 1,000 features about each student, right? Now PCA gives you the top 10 features, new ones, which probably covers 90% of the informations. Okay. All right. So then we established that this is the basic idea. All right. And then what we said, the whole PC analysis, if you take X and Y as two features, right, the whole PC analysis is to capture what? The information of the data. Graphically, if you're looking at XY as two variables, طبعا this analysis, graphic analysis, it will melt down if you have 100 variables. يعني you cannot apply it. But we're using two variables here just to to simplify the concept. Okay, حتى المفهوم يخش براسنا. All right. If you are looking at this graphically, you are really capturing the information in the data. And where are the information? You're really looking at this axis that capture this spread of information, right? The information will be spread at certain axis. You are looking for that axis. All right, and we'll see that once we are said and done, we'll see that really we are looking at the line that best fit the data, right? That this is what we mean by capturing the information. And if we do that, as we stated last time, we're really looking at this best fit line, which maximizes the projections on the axis. This new axis. We found out that the best fit line is this dashed this dashed line. So what I said is that so if we want to capture the best line, the best line is this dashed line, the black one, right? And it really has the maximum scores. If you look at any other line, it doesn't have that maximum scores. We will add those distances and we'll say this is the eigenvalue for this line. All right. Okay. All right. Now, eigenvalue, we talked about eigenvector. And the eigenvector is the vector that points to the direction of this line that you find out. And it has a length of unit length of 1. All right. And we'll see it. It's in our analysis. And you can see here that this V1 here, which is the eigenvector, if you really express it in terms of these two variables, it has two components, right? V1 and V2, right? And both are like I'm sorry. If you look at V1, which is the first eigenvalue, you can see that it consists of X and Y. That means we are creating a feature, which is in this case V1, which is a combination of the original features. نرجع على the difference between two class of algorithms: selection, projection. Selection, select one or two of the existing features. Projection, create new ones. Okay, that's a fundamental change, a fundamental difference in the understanding. معايا all right? Okay. طيب. All right. So, and then we said, okay, once you find V1, which is the first eigenvector, you can find the second one by having the orthogonal V2 as being orthogonal. Why orthogonal? It's the maximum uncorrelated vector. And if you dot product uncorrelated vectors, what will be the result? 0. 0. They are not related at all. Okay. So we are looking for the features that are not related, or the eigenvectors that they are not related, which will create features that are not related. Because simply correlated features waste space, right? It wastes space. Uncorrelated feature captures the essence of the data. And there are few of them. And that's exactly what we are after. Okay, so now, okay, so then we went into and we looked at, we said, all right, the information that we captured in the graphically, we said for PC1, we computed the eigenvalue by adding those projection blue lines for the first principal component. We computed the eigenvalue of the second component of the second PC. How did we add for the second one? Well, for the second one, those are the red ones are for the second one. Okay, the projections of the red ones are for the second PC component. The blue ones are the projections for the first principal component. Add the blue ones, you will get the first eigenvalue. Add the red ones, you will get the second eigenvalue. Okay, and once we did this math, we realized that we have first eigenvalue of 20.2 and second eigenvalue of 1.2. That means what? If I want to compute how much information I can retain by just using the first component, that is very easy. Divide the eigenvalue of the principal component over the total eigenvalues. So if I just use the first principal component, I will divide 20.2 over 20.2 plus 1.2, that comes to 94.4, which means if I just use the first principal component, which اللي حسبتها اللي هو البست fit, right? A dotted dash line, I will have 94.4% of the information. Okay, that's what we stated last time. Then we said, okay, we understood this graphically. Let's have some math هلا. Okay. You see, graphically for simple stuff in math, now you do for complicated features. If I have a list of all the Jordanians and I have attributes for all of them, let's say, for example, I have 1,000, 10,000, 100,000 attributes for every resident. Now I have 10 million plus 10,000 per person. That's a huge database, right? Why would I retain all these features? Maybe at the end, I can create 2 new 3 features for all the population. Okay, now, so we went over those steps last time, and let's go over them one more time in the example. Okay, so let's say, okay, we said we're going to use the same example. We're going to compute the principal component for these points, right? We did that graphically. Okay, so first of all, the standardization step, which is basically has 2 steps, one essential and second optional. The first step, we said, move the data to the center. Equivalently in math, what do? We compute the average and we subtract it from the points. This is equivalently in the graph. You are moving the data to the center. So that's basically what it is here. We are moving the data to the center. Okay, and once we move the data to the center, we have now new coordinates, right? Or values, let's say, for the sample, 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 and for the sample. We'll use these points for the rest of the analysis. Now, the optional step, by the way, if you divide by the standard deviation, right? That's an optional step. Now, then we say we're going to compute the covariance matrix, and we define the covariance matrix here by various variables across the diagonal, various of x, various of y, and the covariance of the variable in the other locations. Check out the formula. And we did the computation. We turned out to be these numbers, and we plugged them here. We got the covariance matrix. Now, what do I need to do? We will use the covariance matrix to compute the very first thing, eigenvalues, right? The eigenvalues, that's my first computation. Then the eigenvectors, right? And there are standard formulas. This formula here, determinant of, you multiply the eigenvalue by the identity matrix. These are the eigenvalues as variable, minus the covariance matrix. You set it to 0. You get a linear system here, and you solve this linear system, right? Right? You solve it, and you get 2 values. Eigenvalue of 1 and eigenvalue of 2. Oh, watch. These are the same eigenvalues in حسبتهم graphically. Yes. So these are the total scores. The first eigenvalue, the total score, the total blue dashed lines, right? This the total scores for the first principal component and the total scores for the second principal component. Okay, so we get this now. Then what we do, we compute now the eigenvectors. We use another equation for that, which is, okay, the eigenvalue times the identity matrix times the covariance matrix. It is equal times these eigenvectors, right? You multiply by the eigenvectors, you get the 0 vector here. And you apply your math here, and then you find out that this is the first vector, and this is the second eigenvector, right? Please go over the math. All right, please go over. The math is simple. You just need to practice on it. Okay. Now, what we said is that once we find the eigenvalues and the eigenvectors, now we need to find the new coordinates or the scores or the projections on the new scale. Okay, so now if we go to the graphically, what it means is, right? What it means, I need to compute. Now this becomes my new axis, right? I need to compute these coordinates, these points, the projection of these points here, 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 right, on this new axis, on this principal component. And how do I do that? Well, we multiply the coordinates of the points times the unit vector. So if we go to this step here, we say, all right, okay, so now these are the points here. I start with these. This is the sample here, right? X and Y, but be careful, use the shifted values, the values that what? Move to the center. So I have to subtract the average values, which I did in the standardization step. Then what we do, we multiply this by this vector. Okay, you can see this vector, unit vector, times this point here, which is right here, and I get 5.66, which is this point. What is 5.66? This is the new coordinate, new value, new score of the this sample using PC1. Right? Why I used this vector here? Why? Because this represents PC1. This is the first eigenvector. And if I multiply it with the sample value, it will give me the score in the first PC vector, the first PC value. Similarly, I do it for this point, for this point, for this point, and this point, and I get these results. Then I need to multiply with the second eigenvector, right? With these points here at the top to get these points, right? And now what do I have? I have the scores or the new coordinates, right, of the data of the sample using the new features. Okay. All right. So suppose, for example, I say, all right, so here is the representation of, forget now about X and Y. Now I use PC1 and PC2. Now notice how PC1, and that's really the key thing here. Notice how PC1 spreads the data. That's typically what you need from a principal component analysis. It gives you those features which spreads the data, right? Now notice how little the data spreads around PC2, right? Because that's why it has a value of 4.4. It retained that much, or 6 point something of the information. Okay, if I just get rid of PC2, I can represent the data only using PC1, which is one feature. And in that case, I am accurate by 94.4% of the time. Okay, and on that accuracy, to highlight that accuracy, this is where we will look at the second example. So yeah, this is now the contribution. So now, before we go to the second example, so we see the PC contribution, the percentage of the total variance explained by the PC component. So the contribution of PC1, its eigenvalue over the total eigenvalues, and for PC2, its eigenvalue over the total eigenvalues, and these are the percentages. And obviously, PC1 explains the data with high percentage. Okay, you have to understand that these are cooked up data. Right? I made this data to look like this. In many instances, things are not as smooth as you can see. Now, let's take a look at an example, a real life, well, not real life, as close to a real life as we can, right? So Here is a manager wants to hire a bunch of candidates or interview a bunch of candidates. And these candidates is Ali, Yasmin, Aya, Sami, Khalid, Tariq. And for every, so these are the samples, right? And for every candidate, we have different features: age, years of education, experience, interview, the point they got in the interview, publications in journals and conferences, and awards. Okay. And what we want is this manager decided that whoever has the highest total, right, we will consider him top candidate. And this guy, in this case, who has, was it Khalid? Probably, right? Total points. Yeah. So now what we want to do is this manager says, you know what? There are too many features here that I look at. Now, this table is not really real life. In a real life table, this table could include other stuff: address, GPA of high school, right? Interests, are how social you are. Are you a team player? Have you engaged in projects similar to our projects? What are so for example, you run a background check on the person, and he ended up, this person, for example, he has an incident with the law. يعني, I don't know what problem, uh, got in a fight with somebody. Yeah, you have too many things, right? You have just too many things you are feeling about people, and you want to, really pick the candidate that gives you with the maximum score. So too many details. As a manager, when you have hundreds of candidates and you have hundreds of features, you want to simplify the process. So here is we says, okay, PCA, help us here. PCA, please help. So we say, all right, what we'll do here is that we are going to run a PCA analysis. And you can see when we ran the PCA analysis, and obviously the very first thing, we will center the points and divide by standard deviation. And this is for the standardization step. Okay. Now, um, now watch. We ran the PC analysis, and we got PC1, PC2, PC3, PC4, PC5, and PC6. Okay. Now, now the explained variance, right, which is basically how much information every PC has. Okay. Now PC1, notice that it has about 90% of the information. Oh, that's very strong. That's very strong. And there is a reason for that. How do we know what's the reason? Watch here. When we look at every feature here, like age, for example, okay, watch the variance, right? Variance is high. Watch for example, the experience. Variance is high, right? Now, look at how, was it years of education? Yeah. Look for example, now look at these. This is the eigenvector. Look at when it comes to experience, which has high variance. Look, this experience has very high contribution here. So this first component took a lot from where? From the feature which has high variance. شو معنى high variance? High variance, the data differs. The data differs, meaning this guy has 1 year of experience, 10, 20, 0 experience, 15 years of experience. Should various indie a lot. It's a very discriminant feature versus age 22 years old, 22, 22, 21 and a half, 22 and a half. What about this feature now اللي بعطيك إياها? It's not discriminate. The variance is minimal. It's useless. For the most part, it is useless. ولذلك the first component is very aggressive. It will take more from the features which has high variance. In this case, the feature which has high variance is what? The experience. لاحظ the components of the experience, a large 0.68, and it's taking a lot from that feature. But take, for example, years of education. Years of education, all of them have similar standard deviation 0.67. Very small standard deviation. ولذلك لاحظ 0.037. It took from the first component, it took from that feature very minimal. But it takes from every feature, but from the feature which has less standard deviation, less information, because it's a useless feature. Okay, so you can see here, you can convince yourself how PCA is a smart algorithm. It builds, especially the very first features. These features take a lot from the features with the high standard deviation. Okay, so now, so you can see the very PCA components. It has explained variance of 89.5, second one 6.4, third 3.0, etc. لاحظ الأخيرة يعني almost nothing. Okay, now, okay, so we computed our, and these are the eigenvectors, by the way. حسبوا وخلصنا. Okay, now, so this is the explained variance. As I add the first component, I'll get up into 89. Then if I add the second one to the first, more explained variance, more. So the more you add, the high explained variance you have, the more information you have. Okay. Now, so now what we do, we compute the scores, right? We multiply it dot product. So this is my eigenvectors times this data. So I give the scores, لعلي, and I show you how you compute those. Meaning I compute the scores of the data using the PCs. So take a look here. This is my original data, right? This is my original data. And this is PC1, the scores of the data using PC1. Now, the interesting part here is that, notice that in my original data, Khalid had the highest points. Likewise, in PC1, Khalid has what? The highest points. Because PC1 captured 89 or 90% of the data. Right? Makes sense. Right? Highest points in the original data, highest points using PC1. Makes sense or it doesn't make sense? It does make sense. It does make sense. Okay? All right? So, طبعا لاحظ انه we are using the scores in PC1. In the new features, we find the data. Which is وخالد in the PC1, what's your score? طبعا what we did, we multiplied الpoint تبع الsample تبع خالد by the eigenvalue of eigenvectors of the PC1, and we got 9.685. Okay, so that makes sense to me. Khalid has the highest points originally, highest points with PC1. So now let's take a look at who's the second candidate in as far as total points. Well, the second candidate is Aya. In the original data, it scores 56. احنا خلصنا من خالد رقم واحد, second highest is Aya. Let's see if Aya does what? If has the second highest points using PC1. Well, it turned out she does. She scores 2.789. She's the second highest on the PC1. Okay, let's look at the third candidate, and here where the trouble starts. Well, it's not trouble because there is a limit of how much PC1 can give you. The third candidate, according to the original data, is Yasmin. However, PC1 is saying, la, it is Ali. All right. And that is when we got into the error, Hassan. Why error? Well, because notice that PC1 is giving you 89.5% of the information. It is not giving you the 100% of the information. Okay. So there is so much accuracy and limit for that. Okay. So now, what do we do? Well, what we do now, notice what we have here. This is my original data, right? And this is when I'm adding the points using PC1, and I'm adding the points using PC1 and PC2. I'm adding the points using PC1, PC2, PC3. That's the top table. What it does is I am adding the total scores from PC1 or PC1 and PC2 or PC1, PC2, PC3 إلى آخره. Okay, and then what I did, here's what I did. I ranked these guys based on what I see here. I rank them. طبعا notice that, let me see if I okay, sorry. Notice that the correct ranking is what? Khalid, then Aya, then Yasmin, then Sami, Ali, Tariq. That's what the original data says if I add the points. Now, if I add things in PC1, we know that we got Khalid correct, we got Aya correct, and then the third and fourth position, we got them wrong. طيب, what happened if I add PC1 and PC2? PC1 and PC2, still we get them wrong. How about PC3? طيب, had PC1 and PC4, this one here. We added PC1, PC2, PC3, PC3. Then we got first Khalid, Aya. We got Yasmin correct. Watch. And then, oh, Ali and Sami are switched from here. And then Tariq بالأخير. Notice Tariq always al-akhir because he has the lowest point. طب why is we still have Ali and Sami? We are still confused with them. Exactly. قريبين جدا مع بعض. Let's go to the original points here. لاحظ where is Sami? Here is Sami and here is Ali. 50 and 49 point. This is noise. For this analysis, it is noise, right? But look at Tariq. He's 46. So he's always the lowest. We don't make a mistake with him, right? So what is the conclusion of this exercise? The conclusion of this exercise is that when you run PCA analysis, you will get the highest information with the first component. Then you get few percentages with the second, few more with the third, etc. If you want an accurate and simple analysis, you have to tell me where is your accuracy. For example, in this exercise, if the manager is interested with the top candidate, باخد PC1 وخلصنا. That's it. PC1 does the job, right? it gives you the first candidate. اخلص يا مواطن. Don't have to captures 80% of the, and you are done. But if you're really looking at the top 2 or top 3, you might want to need to include more, right? So if you have, for example, original data has 1,000 features, you might run into up to 10 features to get really into the depth of the third, fourth, and fifth place إلى آخره. Okay, without making any mistakes. And that should explain, by the way. خلينا هسه نرجع على الديفينيشن اللي حكينا عنه في أول الكلاس. خلينا نشوف this makes sense of PCA. All right. Now, if this makes sense of PCA, and it says, right, and I like to close the loop here. PCA is dimensionality reduction method to compute principal component, minimizing information loss. You need more accuracy, include more components. طيب, The ith principle is a unit vector which perpendicular to the first I minus 1 components and the best fit for the data. And then لاحظ هنا the significance of the principal component decreases as the number increase. PC1 has more information than PC2. PC2 has more information than PC3. PC3, etc., etc. Okay? Where is the cutoff point? You tell me how much accuracy you want. Okay? All right? Okay, so I think I have explained here what I want. Any questions, please? Please ask question. Because this is recorded, it doesn't mean you don't ask question. Yes. Let me hear you first. عليني صوتك. PC5, so the question here is PC5. So this is here. I think it was very minimal, but I'm not sure if... Okay, so if you look at PC5 and PC6, their eigenvalues at the bottom here, see here, see for PC5, the eigenvalue is very small. PC6, يعني it's almost zero, but it's not a zero. So very small, very tiny. Because understand that number of principal components equal number of features. So I'm giving it to you here, يعني, right? You have 6 features, you have 6, but you don't need or you don't have to take all of them. الشطارة, the smart thing is to take the top 1 or 2 or 3, and that will simplify your analysis. If I have 6 features and I make 6 principal component analysis, where is the value? Okay, the value is that take 1 or 2. If I have, let's say, for example, 100 features and I pick the top 10, now أنا استفدت. Okay, so that's... Any questions? Any questions before I... شوية. Okay. What's your question? Okay, so the question here is that what happened if in PC1, right, the did not do the good job on selecting the first one. Let's say, for example, the very first candidates, right, are very close, right? So they are in the noise margin. Okay. Typically, what you do for these things is that when you run these these type of analysis, I wouldn't discount. Let's go here into the example. Yeah, let's see. So here, okay. Notice here, I wouldn't drop, let's say, PC1 plus PC2. I will not drop it unless it is conveying the same information as PC1. So if I do PC1, I get certain ranking, let's say, and then I do PC1 plus PC2, and I get the same ranking, and I'll do PC1 and PC2 and PC3. All are giving the same ranking. Then I'm very comfortable in discarding PC2 and PC3. But if I do PC1 and I get a ranking, and I do PC1 and PC2, I get different ranking, it means PC1 and PC2 is more accurate. But do I stop here? لا. Let me take PC1, PC2, PC3 عشان أطمئن. If I get the same ranking of the top 2 or the top 3, then I can drop PC1, PC2, PC3 because they are not adding for me anything. Okay, so that's how I'll do it. That's how I throw out data. In other words, really, I would stop where I will stop where there is no use of the principal components. I'm gonna come here and stop the recording of this lecture. And after I stop the recording, let's see if I come over here and I say record. Stop the recording. This recording